Hi, my name is Jake McKenna, and today I'll be providing a comprehensive overview of BERT. The following is a high-level overview of BERT. BERT, bidirectional encoder representations from transformers, is a neural network-based language model developed by Google in 2018. By using bidirectional context, it improves language understanding over previous models. Its pre-training allows for generalization, while fine-tuning enables adaptation to specific NLP tasks. Here are some key concepts of BERT. Rather than only considering one direction for context, BERT's novel contribution is the incorporation of both directions when determining the context of a word. BERT looks both at previous and following words to fully understand the context of the particular word it's examining. BERT's pre-training tasks are built upon the concept of bidirectionality. We'll examine them individually in later slides. BERT is built upon the transformer architecture that was first proposed in the paper Attention is All You Need from 2017. The transformer is a neural network architecture using a self-attention mechanism that greatly improves upon previous neural network structures by incorporating parallel processing and positional encoding of words. BERT is built entirely upon the transformer's encoder component, which is key to strong language understanding capabilities. BERT employs multi-head attention, multiple self-attention mechanisms that run simultaneously on different parts of the sentence to give a wide array of context. In summary, BERT is built upon the concept of the transformer, and its most novel contribution is in its bidirectional pre-training. Next, we'll move on to BERT's model architecture. The first component of BERT is an unsupervised pre-training step. This means that its training data is not a human-labeled set. The goal of this pre-training is to create a generalized model capable of high performance across a wide range of NLP tasks. BERT was trained on two types of tasks, a masked language model task and a next sentence prediction task. Both pre-training tasks were created using the book corpus of 800 million words and the English Wikipedia of 2.5 billion words. BERT is trained on both MLM and NSP simultaneously, seeking to balance optimization for both token level and sentence level contextual learning while keeping bidirectionality in mind. The first component of BERT's pre-training is the masked language model, or MLM. MLM is an unsupervised training task where BERT is asked to fill in a masked word in a sentence. An example of an MLM task might be a sentence like, "It's sunny out, so I plan to go to the blank to tan today." A unidirectional context might return words like park if it was looking left at the beginning of the sentence, or tanning salon if it was looking right at the end of the sentence. BERT, using its bidirectional context, could determine that the fill-in word might be pool or beach. Sentences were tokenized using the word piece tokenization algorithm. 15% of all tokens in a sentence were masked at random. 80% of masked tokens were just labeled as masked, where 10% were changed to a random token and 10% were unchanged. This was done to mitigate a mismatch between the pre-training exercises and the fine-tuning exercises that we'll talk about later. The second pre-training task that was given to BERT was next sentence prediction, or NSP. In an effort to address NLP tasks that require an understanding of sentence relationships, such as question answering or natural language inference, BERT was given the NSP pre-training task. The NSP task was based on a subset of sentence pairs that were selected from the pre-training data. 50% of the sentence pairs were given to BERT in an unaltered order. For example, a sentence A would correspond to the first sentence in a logical sequence, and a sentence B would correspond to a second. Those were labeled is next. The other half of pairs were given to BERT in an altered order to replace the B with a random sentence, C. For example, a sentence AB would instead be AC. One example of an unaltered pair might be, "There's a sale at Best Buy today, let's go get a TV." It follows a logical flow, and BERT would be tasked with recognizing that that was an unaltered pair. A not next or an altered pair might be, "I heard TVs are on sale today, I'll have a vanilla cone with sprinkles." And BERT was tasked with recognizing that those sentence pairs don't have a logical relationship. It's worth mentioning that the NSP and MLM tasks were run in parallel during pre-training so that BERT had token context and sentence context baked into the pre-trained model. The next step for BERT is supervised fine-tuning. After BERT has been pre-trained, fine-tuning can be used to create a highly performant model targeted at specific NLP tasks. Compared to pre-training, fine-tuning is a relatively inexpensive process, enabling the NLP community to leverage BERT for a wide variety of tasks without significant financial or time investment. For the purpose of the original paper, BERT was fine-tuned for 11 NLP tasks and achieved state-of-the-art results in all of them at the time of publication. Each fine-tuning method is specific to the task being trained for. This fine-tuning step is supervised, so the data that you're training against is labeled for that specific task. The purpose of separating the pre-training and the fine-tuning is to show that there's a carryover transfer of knowledge from the pre-training task, which is more about general language ability, and the fine-tuning tasks, which are more about specific task ability. One way to think of the difference between the pre-training and the fine-tuning in a human context is like the pre-training is going to college, going to school and getting a general education, and then fine-tuning is on-the-job training specific to a career or a trade. Lastly, model sizes. BERT was trained at 2 model sizes for this particular report. The BERT base model was smaller with 110 million parameters, and BERT large was obviously larger with 340 million parameters. And there was a significant increase in performance between the base and the large models. In summary, BERT's training is divided into pre-training and fine-tuning. This enables BERT to transfer learning from the pre-training to downstream fine-tuned tasks later. On to the next section, benchmark results. BERT was tested against the General Language Understanding Evaluation, or GLUE benchmark. GLUE is a collection of diverse natural language understanding tasks including multi-genre natural language inference, core question pairs, question natural language interface, and many others. BERT base and BERT large both outperformed all contemporary models at the time of publication. Next, BERT was tested against the Stanford Question Answering Dataset, or SQUAD, versions 1.1 and 2.0. SQUAD version 1.1 is a collection of 100,000 crowdsourced question-answer pairs. Given a question and a passage containing the answer, the task is to predict the span of text within the passage containing that answer. SQUAD 2.0 improves on 1.1 by incorporating the possibility that no answer exists in the passage. In both cases, 1.1 and 2.0, both BERT large and BERT base outperformed all state-of-the-art models at the time of publication. And finally, situations with adversarial generations, or SWAG. SWAG is a dataset with 113,000 sentence pair completion examples that evaluate grounded common sense inference. Given a sentence, the task is to choose the most plausible continuation among 4 choices. Unsurprisingly, given the initial pre-training of BERT, it outperforms all state-of-the-art models at the time of publication. BERT's fine-tuning step allows for the creation of task-specific BERT variants that significantly outperform state-of-the-art models at the time of publication. Next, we'll look at ablation studies. Ablation studies are when creators of a model try to remove individual pieces of that model to see what their impact on performance are. In the context of BERT, the authors retrained variants of BERT without NSP or the bidirectional context. The authors instead tried to retrain the model with bidirectional long short-term memory, which was an alternative older bidirectional context method without self-attention or the transformer architecture. All ablation studies show a reduction in performance across evaluation tasks. This indicates the importance of all the components in BERT's architecture. It is worth noting that in future studies, there are versions of BERT that were trained without the NSP pre-training step that exceeded BERT's performance. In summary, ablation studies indicate that both bidirectional context and NSP training positively contributed to BERT's NLP capabilities. In addition, BERT's model size also increases scores across all tasks, indicating a positive correlation between model size and performance. In conclusion, BERT provides a well-tested architecture for two-stage training of bidirectional transformer models. By incorporating bidirectional pre-training, a wide variety of fine-tuned models can be constructed for NLP tasks. Ablation studies indicate that the structure is sound and the model scales well to larger sizes, thereby opening the door for future improvements. To give some broader context around the importance of BERT at the time that it was created, BERT opened the door for a variety of fine-tuned models that didn't require people to go out and pre-train giant models that were frankly outside of the scope of most individual researchers' capabilities. BERT can be thought of as kind of a watershed moment in natural language processing, both because of the bidirectional training that revolutionized the way that people pre-train models, but also the pre-training and fine-tuning steps made it so adaptable and so easy to use, plus its open source nature, that it was kind of inevitable it would get adopted across the board. If you want to learn more about BERT, I would definitely direct you to the Attention is All You Need paper from 2017 that came out of Google. That was kind of the underpinning of where the BERT model came from, and you can track a lineage from the creation of that to the addition of bidirectionality and this two-step training that made BERT so adaptable. Thank you for your time.